Now come to the point, and we have many background processes in PostgreSQL database. So let's discuss the major background processes one by one. So creation, management and termination of PostgreSQL server process is the responsibility of one of the main major background process, that is the postmaster, which is responsible to keep the database running smoothly. And the postmaster process initialize the PostgreSQL server during the startup. It set up the shared memory, start the other background processes, and listen the incoming client connection as well. And also during the shutdown process, postmaster ensure that the all client connection are terminated gracefully, all background processes are stopped, and all data is written to the disk to ensure the consistency. And also in event of backend process crash, the postmaster detect the failure and also initiate the crash recovery process as well. And after the crash recovery, the postmaster restart the affected processes to ensure the normal operation. And the postmaster default port is 5432 for the incoming client connection. So the postmaster managing the overall operations, process control, system interaction to ensure the reliable and efficient database functionality. And second one is background writer. So the primary task of this background process is periodically write the dirty patches from the shared buffer to disk, and this helps in keeping the buffer cache clean and ensure that there is always the free space available for the new data. So this background process is responsible to write the dirty buffer, means those buffer which has been changed in memory but is not being write to the disk, so it need to be write on the disk. So this background process is write these dirty pages, the dirty buffer to the disk from the shared pool or shared buffer. So the background writer ensuring the efficient buffer management and reducing the IO load on the backend processes and contribute to the smooth operation of database. So third one background process is wall writer. So let's discuss about the wall. Okay. So basically PostgreSQL use wall to ensure that the all changes to the database are logged before they are actually applied. This means that any transaction must first record in the wall before the changes are made in the database. So this ensures that in case of crash recovery, the database can recover to a consistent state by the use of wall record. So wall writer basically write those records which are exist in the wall buffer, and so wall writer is copy this wall buffer record from the buffer into the wall files which is on the disk. So similarly, PostgreSQL is not directly write data in, in actual data file. So PostgreSQL first the changes in a wall buffer. Okay, and after some time these changes record in the actual data files. And fourth one is archival process. Basically archival process is responsible to make a copy of wall files, make a actual copy of wall file in another location. You can place on another location, you can also place on the same location as well. And the wall archive files is used for the backup and recovery purposes, and allowing for the point in time recovery and ensuring there is no transaction data is lost even in the failure. And wall archive process can be enabled by the use of three memory component. This is archive underscore mode, archive underscore command, and archive underscore timeout. So we can define this parameter in PostgreSQL configuration files to enable the wall archive file process. And sixth background process is stat collector. Stat collector is responsible for gather the statistical information about the database activities, query execution, and resource education as well. So in a similar way, the stat collector gather the information about the database activity, include the tables, index, access, number of row inserted, updated, deleted, and more. And this data is used by the query planner to make informed decision about the most efficient way to execute the query. So stat collector is a vital component for performance monitoring, optimization by gathering the detailed statistics about your database operations. It also helps the query planner to make the informed decisions aid in the auto vacuuming and provide the valuable insight to DBA for tuning and troubleshooting the database system as well. And we have to take the stats of our database and tables on a daily basis, and we can schedule this job in our non-peak hour as well. Checkpointer is also a important background processes of our PostgreSQL database, which ensure the durability of the database changes by retaining the dirty buffer from the shared pool to the disk, thereby minimizing the risk of data loss in event of system crash. So the primary function of checkpointer is to return the dirty buffer from the shared memory to the data file on our disk. And it is essential for maintaining the data integrity, ensuring data consistency, and optimizing the crash recovery time of your PostgreSQL database. And with respect to the performance and storage, that is a very important background process of the PostgreSQL database. So PostgreSQL, when a perform update a row, it will mark this row as a dead tuple and insert a new row in a blocks. Okay, so this row will be marked as a dead tuples. So auto vacuum process will detecting this dead tuples and reclaiming the storage occupied by these dead tuples. So this is the very important background process which will improve our query performance and our execution plan will be better if our data tables removed from our database or our table, and that is a automatic background process which performing vacuuming automatically in the backend of the database. And these are the two background processes which use for the replication purpose. So whenever primary send the record to the standby side, so vault receiver receive this record and apply the changes to the our replication side, and the vault sender is responsible for sending those records from primary to our standby service. So wall receiver is the receive the record and apply to our standby side, and the wall sender is send the record from the primary to our standby database.